Hello everyone, welcome to Introduction to 3D Modeling and Printing course. In this video, we'll apply all the concepts that we learned during the course number 2 by designing a real product, which is a bug catcher. Here we can see how the bug catcher looks like. It's a project that can be found on Thingiverse, and we can see in the description of that project the author saying, "We live in an old house with lots of bugs, so until I can figure out how they are getting into my house, my family wanted a way to take the bugs outside without touching them. So I created the bug catcher. It turned out really good and it was a fun project. It opens and closes just like a pair of scissors." So how did this guy design the bug catcher? Well, it doesn't say more than that in the description, but for sure he took into consideration the physiological concepts of design. So let's try to design this from beginning, and let's see how we can design this having the physiological concepts in mind. Okay, so in order to design a thing, I will start with a sketch on the paper. In that way, I can modify very rapidly what I did wrong, and I can explore various types of design. So I said that I will want to create a bug catcher. Okay, so what will be the purpose of the bug catcher? What it will afford? So it will have holes that afford fingers insertion, and we will have a cup that affords catching the bug. Okay, so the thing will be that I'll have this, but with the cup attached here, and when I'm doing this action it will open, when I'm doing this action it will close. Okay, so this it needs to do. So that means that we will need two handles like that. Here will be the bug. Here I'll put the fingers. Good. But now I need to think about some constraints. So I really want to make very clear constraints here, because I wanted to make it for small bugs. And here I want to communicate to my user that here I shall have two fingers and here one finger. So I will put constraints in order to communicate to the user how many fingers needs to fit in each hole. Because as you can see, when I'm holding a scissor, I have the need to put here two fingers and here the index fingers. This is a very bad design because I really feel like putting this figure outside, and it's a very bad position for my hand. Okay, what about mappings? So we have mappings between holes and fingers, suggested and constrained by appearance. The feedback. So we need feedback. That means that when we catch the bug, to be sure that was in the box. So we will make some holes here so we can see the bug. And the conceptual model, well, implications clear of how the operating parts work. And signifiers, we don't need it because we have constraints and affordance and mapping and feedback, so signifiers are not needed. So I will take my scissors and I will start from them. So I will outline my pair of scissors, as I said, and this is a good start. What I will need more is here the platform where I can catch the bug. This will be the height. So I'm making here 1.5 centimeters. And what I want to do is to create this plastic part where the part of the scissors can enter. Good. Now I want to make the sphere. And as I said, I will create some holes so I can see the bug. This should be not that much space so the bug cannot exit after this. So like that. And this is the bug. Okay. And here I will need also part where the scissor comes. Okay. One of the part of the scissors needs to go along with this direction. I think more slim like this. And here the other part needs to take a change into direction. So the two parts can meet here where we have this joint. Okay. And here we'll have one, and here we'll have the second one bigger. Okay, so this is how the idea works. So when I will open, the box will open too. When I'm closing, the box will close too. This is just a sketch that makes me understand how I can design it, but we will go into the Fusion during the laboratories to properly measure and make things. Also, if I want to measure very fast the dimensions that I created, I know that 2 squares is 1 centimeter, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have here centimeters, and here 1, 2, 3, 4, 5 centimeters, and here we have 1, 2, 3, 4, 5, 6 centimeters, and here we have 1, 2, 3, 5, 6, 7, 8, 9, 10, 11 centimeters. Okay, so when we put to Fusion, we can add those dimensions too in order to start the sketch. So as a conclusion, we have affordances, the cup for catching the bugs, so the cup affords catching the bugs. Holes affords insertion of the fingers. Constraints, big holes for several fingers, small holes for thumb, and small cup for small bugs. Mappings, between holes and fingers suggested and constrained by appearance. Feedback, clearance to see the bug, so we can see inside if the bug was catch or not. And conceptual model, implications clear of how the operating parts work. So that was our second course about design. At the laboratories, we will create the bug catcher in Fusion by ourselves, but see you next week for the other courses.